Datar, a system professor in the Chemical Engineering Department of LGIT Ahmedabad. In this lecture, I am going to start new topic of the mass transfer operation 1. So let's start. Chapter name is leaching and topic is multi-stage leaching. We know that in leaching, we are extracting one of the component from the solid by using liquid. In previous lecture, I told you related to the single stage leaching. After that, I explained you material balance for single stage leaching. Now in this lecture, we are going to discuss here material balance for multi-stage leaching. So you can see on the screen, this is the figure for multi-cross current stage leaching. Multi-cross current stage leaching means we are using here more than one stage, and here leaching solvent and solid to be leached are coming in the cross current direction. That's why this is multi-cross current stage leaching. So you can see in this figure, solid to be leached is nothing but feed for this multi-stage leaching. After that, for first stage, leaching solvent is the another feed stream. So for the first stage, there are two feed stream. First one is solid to be leached and second one is leaching solvent. After leaching process, we are getting two outlet stream. First one is leach solution, that is nothing but overflow stream, and second one is underflow stream, that is nothing but E1, Y1 and N1. So I told you in last lecture as well, in leaching process, we are having two feed stream, that is nothing but solid to be leached and second one extracting solvent. After that, after leaching process, we are getting two outlet stream. First one is leach solution, that is nothing but overflow, and second one is underflow. So you can see in this figure, for first stage, we are using here fresh feed, that is nothing but solid to be leached, and we are using here fresh leaching solvent. Beauty of this multi-current stage leaching that we are using here fresh solvent for every stage. We are using here fresh solvent for every stage. So I can say we can increase the efficiency of the multi-stage leaching, or I can say we can increase the efficiency of the leaching by using multi-stage leaching. Okay, so you can see here, after whatever the underflow stream is coming from the first stage, that is a feed for the second stage. Whatever the, I am repeating, whatever the underflow stream coming from the first stage, that is feed for the second stage. And I told you for every stage we are using here fresh leaching solvent. So you can see E1, Y1, N1 is nothing but feed for the next stage. After that E2, Y2, N2, this is nothing but feed, but that is the underflow stream for the second stage, that is feed for the third stage. Okay, so this is nothing but about the multi-stage leaching. Simple language, I can say here we are using two feed streams. First one is solid to be leached for the first stage and second one is leaching solvent. But solid to be leached is the fresh feed that we are using for the first stage. But for the second stage, we are using underflow stream of the previous stage. Similarly, we are using underflow stream of the second stage as the feed for the third stage. Okay, so this is nothing but about the multi-stage leaching. Now we will discuss symbols used in this multi-cross current stage leaching. These are the symbols we are going to use here. So you can see here, capital B is nothing but mass of the insoluble present in the solid to be leached. After that, capital F, that is nothing but mass of the solid, that is mass of A plus C. A is nothing but leaching solvent and C is nothing but solute to be leached. After that, NF, this is nothing but mole fraction, or I can say mass fraction here. So mass of B divided by mass of A plus C in a solid to be leached, means this is related to the feed stream, and this is the mass fraction of the feed that is given by mass of B. Mass of B is nothing but this is the insoluble part, means mass fraction of the insoluble. Capital B is the mass of the insoluble and NF, this is the mass fraction of the insoluble. So mass fraction of the insoluble is given by NF is equal to mass B divided by mass A plus C in solid to be leached. Okay, and this is we are writing here on the insoluble free basis. I can say component B is the insoluble, so we are writing these fractions on B free basis. I told you in last lecture as well, we are taking here all mass fractions on insoluble free basis. Okay, so next one is YF. This is nothing but mass of the solute, means fraction of the solute. You can see here mass of C, that is C is nothing but your solute to be leached. Okay, so mass of C divided by mass of A plus C in a solid to be leached. means the solid to be leached is nothing but your feed stream, and YF is nothing but your mass fraction of the solid to be leached in feed to be leached, in solid to be leached. Okay, that is also insoluble free basis, or I can say component B free basis. Next one is R naught, that is nothing but mass of solution A plus C in a leaching solvent. Here we are not going to use component B because that is the insoluble part, and we are taking here all symbols on the component B free basis, that is nothing but insoluble free basis. So R naught is nothing but total mass of the solution of the A plus C in a leaching solvent. After that X naught. X naught is nothing but mass fraction of the solute, that is the C, mass fraction of the solute C in the leaching solvent, and that is given by mass of C divided by mass of A plus C in a leaching solvent. And we are writing this on the insoluble free basis, or I can say component B free basis. After that next symbols in the outlet stream now. So E1 is nothing but mass A plus C in a leached solid. Leached solid means this is nothing but your underflow, means mass A plus C is nothing but your underflow. You can see mass solution associated with the leached solid is nothing but solution in the underflow. After that N1, this is nothing but insoluble fractions in the outlet stream. I told you insoluble is nothing but inert solid. Whatever the mass of the insoluble present in the feed solid, same amount of the insoluble also present in the outlet stream. So that is nothing but N1. So N1 is equal to mass B divided by mass A plus C in leached solid. Okay, so you can see concentration of insoluble solid B in the leached solid, that is nothing but underflow, and we are writing this fraction also on the B free basis, that is insoluble component free basis. After that capital B, I told you this is the mass of the insoluble. Next one Y1. Y1 is nothing but this is the fraction, mass fraction of the solute C, which we want to extract from the solid in the leached solid. So you can see mass of C divided by mass of A plus C in the leached solid, i.e. concentration of solute C in leached solid. Leached solid is nothing but underflow. Y1 is nothing but mass fraction of the solute to be leached in underflow. Done. After that R1 and X1, these are related to the overflow now. So you can see R1 is nothing but mass solution A plus C in the leach solution, or I can say overflow. Okay, this is for first stage. Similarly for the second stage I can write there R2, R3 like this. For the end stage that is Rn. Okay, I will explain you related to that in the next slide. Before that you can see what is X1. So X1 is nothing but mass fraction of the solute C in the overflow, and that is given by mass of C divided by total mass, that is A plus B plus C, and we are writing this fraction denominator or any mass fraction we are writing on the insoluble component free basis. Insoluble is nothing but component B. So we can write here X1 is nothing but mass C divided by mass A plus C. We are not going to consider here component B because we are writing this fraction, all this fraction on the insoluble free basis, that is nothing but component B free basis. So this is all about symbols used in the leaching process. Now we will see some important points of the multistage leaching. So you can see on the screen, this is the first point for the multistage leaching. This is simply an extension of single stage leaching, in which the leached solid, that is nothing but underflow, in which underflow part are successively contacted with fresh leaching solvent. What is the meaning of this line? In this multi-stage leaching, whatever the underflow stream, one of the outlet stream from the leaching process, that is nothing but underflow stream, that is acting as feed for the next stage, means underflow stream for the first stage acting as the feed for the second stage, underflow stream for the second stage acting for the feed for the third stage. And we are using here fresh solvent to increase the efficiency of the leaching process in all the stages. After that, second point is this may be performed in a batch or continuous fashion. Next is here the leached solid. I told you whatever the leached solid, that is nothing but underflow part is acting as the feed for the next stages. That is nothing but meaning of this third point. I am reading this third point now. Here the leached solid, that is nothing but underflow from the any stage act as the feed solid to the next. So more and more amount of the solute is removed from the solid as we move along the cascade. Cascade means single stage, and here we are using more than one stages. Why we are using here more than one stage? Because we want to increase the efficiency of the leaching process. Means whatever the amount of the solid is remaining in the underflow stream from the first stage, we can extract those amount of the solid in the second stage. After that, whatever the amount of the solid, means remaining amount of the solid is remaining in the second stage in the underflow stream, we can extract that solid in the third stage. That's why we are using here multi-stages. Means to increase the efficiency of the leaching process, we can use multi-stage operation. And last point is the material balance calculation that are done in the single stage are now applicable here to the first stage. This whatever the material balance we have done in the last lecture, that is applicable for only first stage. Now we are going to take here another material balance for the another stages. So how to write material balance equation, we are going to see in the next slide. Now we will see material balance equations for the multi-stage leaching. So you can see here we are using two feed stream. First one is the solid to be leached and second one is leaching solvent. After that we are getting here two outlet stream. First one is a leach solution, that is nothing but overflow stream, and second one is leached solid, that is nothing but underflow stream. And underflow stream from the first stage is acting as the feed for the second stage. After that you can see underflow stream for the second stage acting as the feed for the third stage. In whatever the overflow streams, we are getting one composite leach solution, that is nothing but composited overflow as the outlet stream. That is what we are required from this multi-stage leaching. Now we are going to write here material balance equation. So you can see on the screen, I already explained you symbols used in the multi-stage leaching. Okay, so we are going to write here directly the material balance equations for the all stages and all components, that is nothing but component A, component B and component C. I told you component A is nothing but your fresh solvent, or I can say leaching solvent. Component B is your insolubles, or I can say inert solids, and component C is nothing but solute which you want to extract from the solid by using extracting solvent, that is leaching solvent. So firstly we will write material balance equations for insolubles, that is nothing but component B. So you can see on the screen, for component B I can write for stage 1, that is F into NF is equal to E1 into N1. Okay, I told you meaning of all symbols. F is nothing but mass of the solution, feed solution, that is A plus C. After that NF is nothing but mass fraction of the insoluble, that is nothing but mass of B divided by mass of A plus C. We are writing this fraction on the insoluble free basis. That's why we are not considering here component B in the denominator. After that outlet stream is nothing but E1 into N1. Okay. Similarly, we can write here for stage 2. For stage 2 means we are writing here only for the component B, that is the insoluble part. Means you can see here E1 N1, this is feed for the second stage. After that outlet stream is nothing but E2 into N2. For third stage we can write similarly that E2 N2 is equal to E3 into N3. So for N stage I can write in this manner, En minus 1 into Nn minus 1 is equal to En into Nn. So this is the mass balance equations for the component B, that is insoluble. Similarly we will write now for component C. Component C is nothing but solute to be extracted from the solid by using liquid. So I can write here for solute, that is the component balance you can see on the screen, F into YF, we are writing for the first stage. So be careful about the first stage only, that is F into YF plus R0 1 into X0 is equal to E1 into Y1 plus R1 into X1. So on the LHS we are writing compositions of the feed stream. On RHS we are writing composition of the outlet streams. Okay. So similarly we can write for the second stage, means that is nothing but component balance for the solute C. So I can write here E1 into Y1 plus R0 2 into X0 is equal to E2 Y2 plus R2 X2. Okay. E1 is nothing but it is the mass solution of the underflow coming from the first stage. After that R0 2 is nothing but this is the total mass solution A plus C in a leaching solvent for the second stage. After that E2 and R2, this is nothing but outlet stream compositions, or I can say outlet stream total mass for the overflow and underflow respectively. After that you can see here Y1 X0 and Y2 and X2, this is nothing but mass fraction of the solute C in overflow and underflow. Okay, X1 means X stream is nothing but related to the overflow and Y stream are nothing but related to the underflows. Okay, similarly I can write down for the nth stage in this manner, En minus 1 into Yn minus 1 plus R0 n into X0 is equal to En Yn plus Rn into Xn. I am repeating, we are writing feed stream compositions on the left hand side and outlet stream composition we are writing on the right hand side. Okay. Finally, we can write for the leaching solvent, that is nothing but component A. In this manner, for stage 1, I can write here F into 1 minus YF. 1 minus YF, it is nothing but fraction, or I can say mass fraction of the solvent. I told you total mass fraction is nothing but 1. So, we have taken YF is nothing but mass fraction of the solute. So, remaining mass fraction of the solvent is nothing but 1 minus YF. Similarly, plus R0 1 in bracket 1 minus X0. 1 minus X0 is nothing but mass fraction of the solvent. X0 is nothing but mass fraction of the solute. Similarly, on the outlet stream we can write on the right hand side now E1 in bracket 1 minus Y1 plus R1 in bracket 1 minus X1. Okay. So, similarly I can write for the second stage, that is nothing but whatever the underflow is coming from the first stage, I can write that is the feed for the second stage now. So, you can see here we are writing for the solute only, solute component C. So, you can see here E1 in bracket 1 minus Y1 plus R0 2 in bracket 1 minus X0 is equal to E2 in bracket 1 minus Y2 plus R2 in bracket 1 minus X2. So, I am repeating, we are writing whatever the underflow stream coming from the previous stage as the feed for the next stage. That is nothing but for second stage I can write here E1 in bracket 1 minus Y1, and secondly we are writing here R0 2 in bracket 1 minus X0. This is nothing but related to the leaching solvent, and we are using fresh solvent for every stage. Okay. So, similarly I can write for the n stage in this manner En minus 1 in bracket 1 minus Yn minus 1 plus R0 n in bracket 1 minus X0 is equal to En 1 minus Yn plus Rn in bracket 1 minus Xn. Okay. So, in this manner we can write for the multiple stages. Okay. So, this question can be asked for 7 marks in your exam. Now, we will see overall material balance. So, you can see here overall material balance for stage 1. We are going to write here overall material balance for each stage now. So, for stage 1 I can write overall material balance, means here we are not going to consider mass fractions. Here we are going to consider only total mass of the solution or total mass of the streams. So, you can see for the first stage F plus R0 1 is equal to E1 plus R1. For second stage we can write E1 plus R0 2 is equal to E2 plus R2. Means whatever the feed stream we are writing on the left hand side, and whatever the outlet stream we are adding those stream on the right hand side. For n stage I can write En minus 1 plus Ron is equal to En plus Rn. So, in this manner we can write overall material balance, and I already told you how to write component balance for this multi-stage cross current leaching. So, this question can be asked for 7 marks in your exam. This is all about this lecture. We will see next topic in the next lecture. Thank you very much.